Hi everyone, my name is Diksha and today I am going to teach complex number and quadratic equations. Now, firstly we will learn what does a quadratic equation means. Suppose I have taken the generalized form of this. I have taken the generalized form of a quadratic equation. In this, I have taken the variable x. X is a variable and the coefficient of x square is a and the coefficient of x is b and c is a constant term. In this I have equation, this represent equation, and quadratic means basically in which the degree is 2. As you can see, the highest power is also known as degree, in which we have highest power 2, degree 2, or I can say degree 2, then this is a quadratic equation. Alright, suppose let me take an example. I have taken this equation, quadratic equation I have taken. In this, the coefficient of x square, basically a is 1 and the coefficient of x, b is also 1 and the constant term c is also 1. And I already know how to solve a quadratic equation using discriminant rule. I know the degree is 2, the highest power is 2. In this, I will be finding two roots. And how to find the roots? Using we have discriminant rule. Alright, I have this formula to find the roots. This is the discriminant rule. Alright, so now I am going to put the value of ABC in this formula. I have taken this formula. Yeah. Now I am putting the value. In place of B, I have written 1 and 1 square minus 4 into 1 into 1 upon 2 into 1. Now this will go to 1 square is 1, 4 into 1 is this. Now this was it. I have come across the minus side inside the square root. Now here, from here, the comes the need of a complex number. I already know about natural number, whole number, integer, rational, irrational, and real number. Now, because of this, here we have the minus sign inside the square root. That's why we have come across the need of a complex number. Now, I can write it as this. Alright. And this as well. Yeah. Now, I am going to write iota in place of root minus 1. We denote iota as this. Okay, now I can use it here. In place of root minus 3, I can write it as this. Yeah, so I am able to solve using the complex number. Okay, so this was it. From here, it comes the quadratic. From the quadratic equation, we are able to find the need of a complex number where the iota sign comes. It is denoted as iota. Alright, now iota is root minus 1. If I am squaring both sides, taking square both sides, I have come across the value of iota square as well. Iota square, value of iota square is -1. Okay, now I'm going to multiply iota both sides. Multiplying by iota both sides. Alright, we have come across this -1 into iota is minus iota. So here, and again, I'm going to multiply both sides by iota. I'm finding iota, the value of iota, iota square, iota cube, and I'm going to generalize it after 2-3 steps. Now here I'm again multiplying both sides by iota. This will goes to iota raised to the power of 4 minus iota into iota. Simply minus iota square. And now here I can use the value of iota square as well. This will be this. So we have the value of iota raised to the power 4 is 1. Now, if I'm further going to take the values, if I'm further going to find the values of iota 5, iota 6, I will come from this. Now, I have written iota raised to the power 4 is 1. Now, again I am going to find the value 1 on the multiple of 4. Iota 8 will be 1, iota 12 will be 1. The value of iota power will be 1 on the power of multiple of 4. I can write as this. Alright, we have come across, we will use these values. Alright, what I have written this. Now I will be using these values further when I have to solve. Okay, these 4 values are very much important. Now, how to represent a complex number? Complex number, the standard form of a complex number the standard form of a complex number is z is equals to a plus iota b. Now, complex number is denoted by as z, and here the real part is a and the iota part, the imaginary part is b. But I have written the real part of z without iota part, also known as real part, is a, and the imaginary part of z, that is the coefficient of iota, is b. I am very much familiar with this standard form. Now, for an example, I have taken this. Alright, now this is a complex number. Here I have, let me denote this as z1. Okay, real part of z1 is 2, and what is the imaginary part of z1? Now I have to take a whole. The coefficient of imaginary part, the coefficient of iota, I have to take a whole with the minus sign as well. Okay, because in the general form we have this. Alright, if I have taken, let's suppose I am taking another example. Now here I have the real part as well negative. I'm going to take a whole. This is the real part and this is the imaginary part. Alright, I have to take it with the minus sign. Now, any number that can be written as a plus iota b is a complex number. Now, I am asking to you, my question to you is 4 a complex number? The answer is yes. 4 is a complex number because it can be written as this form. This is the a plus iota form of this. Yes, I can write 4 is natural number, 4 is whole number, 4 is integer. Now here comes to this now. 4 is a complex number. As I can write it in the form of this. Basically, the real part is 4 and the imaginary part is 0. Let me denote this by Z. Okay, here the real part of Z is 4 and the imaginary part of Z is 0. Alright, now let's suppose I'm taking another example. Is this a complex number? Yes. Here I will be writing this as this. Here the real part of Z is 0 and the imaginary part of this is 16. I have to take only the coefficient of iota, not with the iota. Alright. So this was it. We know how to denote a complex number by a plus iota b, and what is the real part and what is the imaginary part. Now, let's move further. If two corresponding values are equal, it means, let's suppose I have saying x plus iota y is equals to 16 minus 6 iota. What does this mean? This must be equal only when the real part is equal to the real part and the imaginary part is equals to the imaginary part. This can only be possible if x is equals to 16 and y is equals to minus 6. I have to take it as whole. The coefficient of iota is, I can write it as this in the general form. Yes. So here I am taking the y, the imaginary part, as minus 6. Okay, this was the real part and this was the imaginary part. Two complex number are equal only if the corresponding are equal. Alright, let's suppose I am taking this example. 4x plus iota 3x minus y is equals to 3 plus iota minus 6. This is the question. Now, if I'm saying this is equal, then this can only be equal when the real part of this is this and real part of this is this. Imaginary part of this is this and imaginary part of this is this. Alright. Now I'm going to equate 4x is equals to 3 and 3x minus y is equals to minus 6. Now I'm going to solve this to find the values of x and y. Yes. And here I can put the value of x so that I can find the value of y in this equation. Yes. Here I have found the values of x and y by comparing real part with real part and imaginary part with imaginary part. Now we always come across the algebra of numbers, like if I have a number 4 and I have a number 3. Now I know what I'm going to do for the algebra. 4 plus 3 I can find, 4 minus 3 I can find, 4 into 3 I can find, 4 divided by 3 I can find. Addition, subtraction, multiplication, division. I have always come across through this. Now I can do the same in the complex number as well. Now here comes another topic algebra of complex numbers. Let's suppose I have taken a complex number z1 as a plus iota b, and I have taken the second complex number as c plus iota d. I have denoted this. I have taken two complex numbers, so that's why I have denoted them with different signs. Okay, this is z1 and this is z2. I have taken two complex numbers. The real part of z1 is a, the imaginary part of z1 is b, and the real part of z2 is c, and the imaginary part of z2 is d. Alright, so what I'm going to do first is that I'm doing addition of addition of two complex numbers. Here I have z1 plus z2 I have to find. What I'm gonna do is that putting the values a plus iota b plus c plus iota d. Now if I want to add these, I can only add the real part with the real part and the imaginary part with the imaginary part. I can write it as this. Alright. Now here, this is the real part of z1 plus z2 and this is the imaginary part of z1 plus z2. I have done the addition part. Now, if I am going to do difference of two complex numbers. Alright, difference I can say, or I can say subtraction of two complex number. I can write it as this z1 minus z2. Now putting the values of z1 and z2. Alright. Now, firstly I am going to open the second bracket. It will be like this. And then I can rejoin the real part with the real part and the imaginary part with the imaginary part. Now this has become the real part of z1 minus z2 and this has become the imaginary part of z1 minus z2. This was it. Now I have to do the multiplication of two complex numbers. How I'm going to multiply them. z1, z2, or I can say z1 was this, a plus iota b, and z2 is this. Now, using the distributive property, I can do this. This step is clear. Now, I will multiply a by c and a by inside. Okay, ac plus iota ad plus and this through this and this with this. Okay. Iota BC plus iota B into iota D. This step is clear. I can write it here as this. And here iota square BD. Now we know the value. We have find out the value of. Here I can use, you have to remember this. Iota square is equals to minus 1. You have to remember this. Alright. Now what I am going to do is that putting the value of iota square. Alright. This has become this. Alright. Now again, real part with the real part and imaginary part with the imaginary part. This will be like this. Now the real part of z1, z2 is this and the imaginary part of z1, z2 is this. I am done with the multiplication of two complex number as well. Now what I am going to do is next is division of two complex numbers. Division of two complex numbers. z1 by z2. I'm putting the values of z1 is this and z2 is this. Now, I know the standard form of complex number was a plus iota b, x plus iota y, whatever I can say. Now, here in this, I am having the denominator with the iota part. Alright, I am having the complex number, the iota part in the denominator, and we and whenever we come across through this, we are going to rationalize it. Okay, how we gonna rationalize it? By multiplying and dividing this with the changing this sign, and here I am multiplying and dividing with the same. Alright, so what I'm going to do next is multiplying the numerator with the numerator and the denominator with the denominator. Alright. Now again using the distributive property on the numerator. And in the denominator, I am able to see this is a plus b, a minus b. I can say it as a square minus b square. Using this identity, I am using here in this is a whole one term and this is whole one term. Okay, so here I can use this formula. Alright, I have used this identity. Now solving the numerator, AC minus iota AD plus iota B square minus iota square BD, and in the denominator C square minus iota square D square. I have opened iota D whole square, it will be iota square D square, and again I can use the value of iota square here in this. This will be this. Alright. So this will be AC minus iota AD plus iota BC plus BD, and in the denominator I have used the value of iota square in the numerator as well as in the denominator. Now this will be this. Alright. Further I can solve this. It will be AC plus BD plus iota BC minus AD. Alright. Is this okay? Now, I have come through this. I can also write the real part of this is this. Let's suppose I am going to write it on the next page. AC I have come across through this. Now this was it. After doing division, Z1 by Z2 have become this. Now this is the real part of Z1 by Z2 and this is a imaginary part of Z1 by Z2. This is real part without iota, and here the coefficient of iota is imaginary part. Alright. We have done this. Now, further, I have to solve some questions let's suppose I have taken this. Now I want to express them in the standard form. And what is the standard form of a complex number? It is this. If I have come to the solution this, I will write it as this. And if I have come to the solution this, I will write it as this. Alright, this is clear to you? Now, if I'm going to solve this, this will be minus 5 by 8 iota square, and here further I can use the value of iota square as this. I can write it as this. I have come to the solution of this. Now I have to represent it in the form of a standard complex number. I can write it as this. Alright, this is clear to you? And let's suppose I have taken another example. I have taken this. Now, we already know how to solve this. First, let's simplify the cube. Okay, I have written this. If I'm taking a cube of minus 1 by 8 iota, I will come up with a minus sign, and this will goes to denominator. This will goes to 8 cube, and here iota cube, and further I can solve them. The first two, this will goes to this, and here iota cube, I can use the iota cube value as minus iota. Alright, now here I can use the value of iota square. This will be this, and here I have this minus with minus, this will be plus. Alright, and here if I'm going to solve this, this will be this 2 by 8 cube iota. I can further simplify them. 8 cube basically means this, and this. Okay, in the denominator I have come with 256. Now this is the solution, and I have to write it in the standard form. I can write it as this. This is the standard form. Alright, and this is the answer. Okay, now if I am saying I have to solve this equation, I have to solve this identity using identity. Now I already know this identity. A minus b whole cube is a cube minus b cube minus 3ab a minus b. Now this is the a, and minus 3 is b, and b is 3. B is whole 3 iota. Alright. This is A and this is whole. Now here in this, I am not finding the real part and the imaginary part. I am going to solve using this identity. So here 5 is a term A and 3 iota is B. Now if I am applying the formula in this, I will be using this A cube minus B cube minus 3 A B A minus B. Alright. And further I have to solve 5 cube is 125 minus 3 3s are 9, 9 3s are 27 iota cube minus 5, 15, 50, 30, 45 iota. Okay. And I can use the iota cube value as minus iota. 3, 8, 45. This was 45. And 45 fives is 45 fives are 5 fives are 25. 225 minus 225 iota plus 45 threes are 5, 10, 35. 135 iota square. Now here I can solve this. Yes, this will be this, and again here I am using the value of iota square. Now this will turn to this. Now solving the real part with the real part. Alright, this will turn to minus 10 minus 198 iota. Now this is the standard form. Here the real part of z is minus 10 and the imaginary part of z is minus 198. Alright. So this was it. How to solve the complex number in the standard form. Alright. Now, I already know this. This was it. Okay. If I'm saying another topic is there, conjugate of z. Now, what is the conjugate of z? Conjugate of z is this. I have taken the bar on the z and I am going to change the sign of the imaginary part. Let's suppose I have taken example this. This is z. Now, what will be the conjugate of z? Well, what will be conjugate bar? It will be this. And if I'm taking the example is this. Now the conjugate of z, or I can say conjugate z bar, it will be this. I only have to change the sign of the imaginary part. Here the imaginary part was 3 and here it becomes minus 3. Here the imaginary part is minus 3 and this has become plus 3. I only have to change the sign of the imaginary part only. If plus, then it will go to minus, and if it is minus, then it will go to plus. This was whole what a conjugate of z is. And I am taking another modulus of z. Modulus of z is square root I am taking a square plus b square. This was whole through this. This was the standard form of a complex number. And here a is the real part of z and the imaginary part of z is b. So here square root of the real part of z plus imaginary part of z is modulus of z. Alright, let's suppose I have taken an example this. 2 plus 3 iota. Now it will go to modulus of z I represent as this. This will be under root 2 square plus 3 square. This will be this. Alright. And if I'm taking this. Minus 3 minus 4 iota. Now the modulus of z will go to square root. Real part is minus 3 and the imaginary part is minus. I can solve it as this. Alright. It is also denoted as R. Okay. Now here comes a relation between Z, conjugate of Z and modulus of Z. This was complex number and this is conjugate and this is modulus. Okay. This is as this. Now, what I'm going to do is that let's multiply 1 by 2. Multiplying equation 1 and equation 2. Z bar, it will be a plus iota b and a minus iota b. Again, I am going to use this identity a plus, let's suppose I have taken another variable x plus y. X minus y is basically x square minus y square. Here I have this term and this term. This will goes to a square minus iota b whole square. Alright, a square minus iota square b square, it will be like this. Okay, now, and there is a relation between this. This is what? This is only the square of the modulus. Yes, if I am squaring this, this will be this, and this is same as multiplying z with z. Now I have come to the relation. There is a relation between a complex number and conjugate of complex number and modulus of complex number as this. Whenever I am going to write modulus of z square, it will open it as z conjugate. Now this is very important for solving. Yeah. And modulus property, I have these properties. Modulus of z1, z2 will open it as modulus of z1 as modulus of z2 and in the division also. Okay, this will open it as this. It will separate. And here, if I am taking the conjugate, z1, z2 conjugate I have taken, it will open it as this. Okay, and same as if I'm going to add and taking this, this will open it as this. And if I'm subtracting two complex number and I have taken conjugate of the whole, okay, this will open it as this. There will be no change in the sign of this. Alright, and here same with the division. If I'm taking the conjugate on the whole, this will open to the conjugate of separate complex number. Alright, now what I'm going to do next is I have to find the multiplicative inverse. Now what does multiplicative inverse means? Multiplicative inverse. Now the multiplicative inverse of 2 is 1 by 2. If I have this 2, what to multiply with this to get 1? Obviously 1 by 2. Here, from here, this concept, the multiplicative inverse concept. Alright, now if I have to do the same in the complex number also. Alright, so find multiplicative inverse of 2 minus 3 iota. Firstly, I will denote the complex number as z. Z complex number is denoted by this. To find the multiplicative inverse of this, obviously, whom to multiply z to get 1? Obviously 1 by z. So, multiplicative inverse of z is 1 by z. So, here multiplicative inverse of 2 minus 3 iota is 1 upon 2 minus 3 iota. Alright, and I have already told to you the complex part, the imaginary part will not come in the denominator. And what we are going to do is rationalize it. Okay, this will be like this. I am going to rationalize it. Alright, I have only changed the sign here. I have only changed the sign of the imaginary part and multiplying and dividing. All right. Now this comes as 13. I have distribute the denominator here to this term and to this term. Now the real part has become this and the imaginary part has become this. Here I have used the identity this. Alright, clear to you? Okay. Thank you.